So generally you see covalent bonds just sharing two electrons, so one pair of electrons. But you can actually see what are known as double or triple covalent bonds. So this is where they're sharing more than one pair of electrons. Again, remember it's always a pair. So a double covalent bond shares 4 electrons, and a triple covalent bond shares 6. Okay? So double bond shares 2 pairs of electrons, or 4 total electrons, and then a triple bond shares 3 pairs, so 6 total electrons. And as you can see here, looking at just a couple, if you're sketching them out, generally you write the atom, okay, and then 2 lines, 2 parallel lines, and then the other atom. And that's a double bond, double covalent bond. Triple covalent, you just do 3 lines between the 2 atoms, okay? So here you can see that the oxygens are actually sharing 4 electrons total, so 2 pairs, making it a double covalent bond. And then the nitrogens are actually sharing 6 electrons, okay, which makes it a triple covalent bond. There is actually no such thing as a quadruple bond, all right? So as you add in more covalent bonds, so you go from a single to a double to a triple, you're actually pulling the atoms closer and closer together. So with a triple bond, you have the most overlap between the 2 atoms. And that starts to put something of a strain on the bonds, okay? And once you get to 3, it's actually as close as you can get them and have the bond be stable. So you can't actually get up to 4 bonds between them, okay? That just is too unstable for the atoms to actually stay together. Okay, so atoms in covalent bonds do not always share electrons equally, okay? Meaning that one atom will kind of take over the electrons more than the other atom. This creates what's known as a polar covalent bond. So nonpolar covalent bonds are when the electrons are shared equally or almost equally between the atoms in a bond. So you're going to have almost equal time with the 2 atoms. Okay, so the electron will move between the 2 of them almost perfectly evenly. Okay, polar covalent bonds are when the electrons are not shared equally between the atoms in the bond. So one of the atoms will kind of take over the electrons more than the other, okay? And that creates what's known as a partial charge, okay? So here you can see we've got, I believe this is NH3, okay? So you have your nitrogen, which is this really big atom right here, and you have each of your 3 little hydrogens, okay? Now the nitrogen is a bit more electron greedy than the hydrogens are. So the nitrogen will actually kind of monopolize the time of the different electrons that are found in the covalent bonds between each nitrogen and the hydrogens. Okay, so each hydrogen is donating 1 electron into this bond with the nitrogen, but the nitrogen is kind of keeping it closer, keeping that electron closer to itself, and then every once in a while it allows the electrons, at least 1 electron, to go around that hydrogen and then come back, okay? Now, basically it will end up looking something like this. Let's see if I can do this here. So you get your electron going around here, and then every once in a while it'll go around one of the hydrogens and then come back and then go around again and then maybe go around there and there, okay? And it'll just keep doing that every once in a while, going around one of the hydrogens, okay? Let's see. And then because of that, because the nitrogen is keeping the electrons more frequently than the hydrogens, it develops what's known as a partial negative charge. So you have the negatives going to the nitrogen more, and then that leaves the partial positive charge on the hydrogens, okay? So that's where you get this polarity? Yeah, polarity, okay? Where you have a a partial negative charge on the nitrogen because it's keeping those electrons for more time than the hydrogens are, and then you'll get that partial positive charge on the hydrogens. And it's partial because every once in a while you'll actually get it evened out, okay, where the electrons go back around the hydrogen. Okay, so it's not a full charge like you would see in an ionic bond. It's just a partial charge. Okay, so finally, we've talked about the major two, ionic and covalent. Okay, metallic bonds are really kind of strange. Okay, so metallic bonds allow both atoms and electrons to move freely throughout the metal structure. Okay, so it's not really a solid structure, especially not to the electrons. Okay, so you get basically these atoms, okay, and you have the nuclei, and those generally get relatively structured. There's a lot of wiggle room in there, but then the electrons just kind of move wherever they want to. Okay, the electrons just kind of hang out. They might like this atom for a little bit, and then they'll jump over to this nucleus, and then just kind of hang out between a couple different atoms, and so on and so forth. So this is actually what gives metals a lot of their properties. It's why they're so malleable, they're bendable. Okay, it's why you can flatten them out. It's because all of this moves relatively easily throughout the structure. Metals can also conduct electricity even when solid because of this, because the electrons are already moving around in the structure. So when you add an electric current, that just kind of gets passed along as well. Right? It's already kind of in that motion, so adding that electric current just kind of gets passed along. They are bendable, flexible, stretchable because there is no like tight, packed structure. Okay? It's more fluid than most solids will get, especially in terms of the electrons themselves. They are generally referred to as a sea of electrons. Okay, where maybe the nucleus is like the bottom of the ocean, okay, and the electrons just get to kind of move around wherever they want to. So this is kind of a depiction of what that looks like. You have the different atomic nuclei in the gray circles here, and then the electrons are the little red circles that are moving all over the place. Okay, so this is kind of the image that you can get when you think of a metallic bond. And this one just kind of cracks me up. So these atoms are not necessarily concerned with keeping electrons next to the nucleus. They just kind of, you know, as long as they're there somewhere, that's cool. So, all right, so that is the end of this section.